This is G-Sync Pulsar, the best and clearest backlight strobing technology that I've used. NVIDIA is finally ready to launch G-Sync Pulsar at CES 2026, and I've already done some hands-on testing to show you today how it works and the motion clarity that it provides. Pulsar is the most advanced strobing tech for LCD so far, combining all the innovations we've seen over the years into a single technology that allows everything to work simultaneously. You get backlight strobing on the level of ULMB2. It works with adaptive sync variable refresh rates, and it uses a cutting-edge rolling scan to provide elite clarity from the top to the bottom of the screen. Let's dive into Pulsar after this. Thanks to MSI for sponsoring our CES coverage. Check out MSI's gaming desktops, inside of which you'll find powerful AMD Ryzen or Intel Core Ultra processors, NVIDIA GeForce RTX graphics with ray tracing and DLSS, and the latest connectivity, including up to PCIe Gen 5 SSDs, Wi-Fi 7, and 5GB LAN. MSI's Silent Storm cooling AI uses smart fan algorithms and separated airflow chambers, combined with up to 360mm AIOs, to keep temperatures low and minimize noise under load. There's tempered glass side panels, clean interiors, and excellent designs to choose from. Learn more about MSI's gaming desktops via the links in the description.
Also supporting our CES coverage is Thermal Grizzly and their Cryo Sheet, an excellent alternative to thermal pastes, and because they don't use any liquid, they can never dry out. These graphene thermal pads offer very high thermal conductivity, are easy to use, are extremely durable, and can be used to maximize your CPU and/or GPU's cooling performance. So for more information, please check the links in the video description. We'd also like to thank Endorphy, creators of the award-winning Fluctus fans, available in both 120 and 140mm. These high-performance fans are designed to move air efficiently in dense spaces, with focused airflow and reduced noise. Perfect for CPU, power supplies, PC cases, and more. So to learn more, please click the links in the video description.
So let's take a step back and explore exactly what G-Sync Pulsar is. The fundamental underlying technology here is backlight strobing, a technique that LCD monitors can use to improve motion clarity. On a normal LCD, the backlight is lit at all times, but this creates clarity issues when objects move quickly across the screen. This is because LCDs are sample and hold monitors, which hold images on screen until the next update. During fast motion, your eyes end up tracking objects that aren't actually moving continuously, and this causes blur. Backlight strobing attempts to solve this by pulsing the backlight on and off. The backlight only briefly turns on when the image on screen has updated. The rest of the time it shows black. This hides most of the hold part of LCD operation and stops your eye tracking objects that aren't moving. Thanks to visual trickery and the magic of the brain, the flicker effect is hidden and your eyes perceive motion as if it's almost continuous with much less blur. This is what G-Sync Pulsar tech is built on, but NVIDIA have taken it multiple steps further. Traditional backlight strobing tech has a number of limitations. Firstly, it pulses the backlight at a fixed rate, so it doesn't work with variable refresh rates. Secondly, it pulses the entire screen at once, but due to LCD scan-out, the image isn't updated on screen all at once, so clarity with strobing enabled changes between the top and bottom of the screen. This has made backlight strobing a technology that is only useful in specific scenarios, typically when gaming at a locked frame rate that matches your monitor's refresh rate, and when you're largely focused on the center of the screen. NVIDIA has taken significant steps to alleviate these issues with Pulsar. The first innovation is getting backlight strobing to work correctly with variable refresh rates, aka adaptive sync. Other brands have tried this over the years. I've tested implementations from Gigabyte, MSI, Asus, but normally what happens is that clarity falls away significantly at lower refresh rates. This makes it almost useless if you actually want to utilize the entire refresh rate range. Typically, there's only a narrow window where these strobing sync technologies actually improve clarity, and occasionally the clarity benefits even at the maximum refresh are not amazing. NVIDIA have worked super hard on G-Sync Pulsar to optimize the variable refresh implementation so that it actually works properly and gives a significant clarity benefit over a much larger range of refresh rates. The second innovation is rolling scan. Instead of pulsing the entire backlight at once, Pulsar uses a backlight that is split into multiple horizontal sections. Then, the strobing pulse is synchronized to the LCD scan-out, pulsing the backlight only in the section that is just updated. With precise timing to allow the LCD to settle as much as possible before the pulse occurs, this creates a clear strobed image from the top to bottom of the screen with minimal strobe crosstalk artifacts. Like with adaptive sync strobing, NVIDIA are not the first company to implement something like this. BenQ did it first with Diac 2, which split the backlight into zones and synchronized the pulse to the scan-out for excellent top-to-bottom clarity. However, Diac 2 did not work with variable refresh. It remained a fixed refresh technology. NVIDIA are the first to get both of these features working together, allowing for rolling scan strobing and variable refresh strobing to work simultaneously. In a way, they're combining all the innovations that we've seen previously into the one package and doing it better. NVIDIA are also continuing to use things that made their previous strobing technologies like ULMB2 work well. This includes variable LCD overdrive and various timing and pulse width optimizations. So how well does G-Sync Pulsar work? To find out, I tested the feature on a brand new monitor from Asus, the ROG Strix Pulsar XG27AQ-NGV, which is set to be available starting at CES 2026, so right now, if not very soon. It's a 27-inch 2560 by 1440 IPS LCD with a maximum refresh rate of 360 Hz. Enabling Pulsar is as simple as having G-Sync enabled in the driver, then enabling Pulsar in the monitor's OSD. The only available setting is for Pulsar low FPS, which I'll talk about later, but other than that, the feature is designed to just work without the need to adjust anything. And it works really well. I'm super impressed with Pulsar as someone that hasn't been a big fan of backlight strobing previously. I just haven't liked the trade-off of needing to turn off adaptive sync, ensure I've got a steady locked FPS at a refresh rate that strobing supports, and all of that just to get a bit of extra clarity. With Pulsar, it really does just work with variable refresh. No flickering as the refresh rate changes, no ugly artifacts or issues associated with trying to run strobing and VRR at the same time. It just happily strobes away and adjusts the strobe as the refresh rate changes. This makes it so much easier to just hop into a game and get playing with strobing enabled. Take Battlefield 6 as an example. I fired up a game, optimized a few settings for high FPS, and was getting around 170 to 200 FPS in-game with VRR enabled. This worked perfectly with Pulsar enabled. Didn't have to change a single thing on the monitor. Strobing provided genuine clarity benefits at these refresh rates, despite being well below the monitor's maximum 360 Hz refresh rate, and it honestly looked fantastic and felt fantastic to play. Previously, with other strobe monitors, if I wanted to play this same game, I'd have to first configure the game and monitor to the same refresh rate. So, optimize settings to lock Battlefield 6 at, say, 240 FPS, which would mean turning down settings, and then lock the monitor at 240 Hz, disable VRR, enable strobing, and ensure that the FPS lock was held during gameplay. This can be quite a fiddly process because any mismatch in FPS and refresh rate can prevent you from getting the clarity benefits of fixed refresh strobing. Alternatively, I could use a monitor that has a strobing sync implementation such as the Gigabyte M27Q3, but then I'd only get very limited clarity benefits in the 200 Hz sort of range, and at times the level of strobe crosstalk in these models can actually make the screen look worse with strobing enabled. All of this fiddliness is eliminated when strobing and VRR work properly together, and that's what G-Sync Pulsar provides. So this is the first time ever that I could recommend you enable a backlight strobing feature the vast majority of the time. Of course, this wouldn't be a proper backlight strobing examination without some Blowbusters UFO test results. Now, the normal browser-based test UFO doesn't support VRR, so I combined this with a utility called SmoothFrog to allow me to run the UFO test at any refresh rate I liked in a VRR configuration. And these are the results. So first up, here's Pulsar at a range of refresh rates run at a high speed of approximately 1920 pixels per second. We have Pulsar off, as well as Pulsar on at 360 Hz, the maximum, 240 Hz with VRR, and 96 Hz. The 360 and 240 Hz images are particularly clear, and while 96 Hz isn't quite as clear as those other refresh rates, this is still an excellent result for strobing at such a low refresh rate, as we'll see in a moment with a few other configurations. The reason why the image isn't quite as clear here relates to the 25% duty cycle, which means a longer pulse width at lower refresh rates. In real life, you get fantastic clarity at pretty much all of the supported refresh rates, and the difference between the 360 and 96 Hz results is hard to spot. Here is a closer look at the benefit Pulsar provides at lower refresh rates. The clarity improvement at both 240 and 96 Hz relative to turning Pulsar off is significant. So even though that 96 Hz result isn't crystal clear, it's an enormous uplift compared to not using Pulsar. Now let's look at why Pulsar is so good compared to other strobing sync implementations. Here I'm comparing Pulsar to the Gigabyte M27Q3 using AIM Stabilizer Sync. At 360Hz, to begin with, there are already artifacts on the Gigabyte image, including much more strobe crosstalk, the double image effect you see, and red fringing due to a slow red phosphor in the backlight. When I move down to 240Hz, the M27Q3 still looks okay, obviously not as good as Pulsar, but you might be wondering why I think Pulsar is so amazing relative to this aim stabilizer sync implementation when this is how it works at 240Hz with VRR. That's because Pulsar works well across a much larger range of refresh rates. Here's the results at 96Hz. Aim stabilizer sync is barely an improvement on the image without strobing enabled, whereas Pulsar is relatively clear with a huge improvement in clarity. This is all with variable refresh enabled, so you can drop into a game at around 100Hz and get these benefits on a Pulsar monitor right away. The other feature Pulsar provides is excellent clarity across the entire screen, from top to bottom. If we look at the results captured at the top, middle, and bottom of the screen, there is very little difference in clarity. The rolling scan pulse implementation works really well, which is fantastic for games that have important UI elements around the edges. These will not be blurry in motion on a Pulsar screen. When comparing this to ULMB2 on the Asus PG27AQN, we see a very different result. ULMB2, which does not use a rolling scan pulse, produces relatively good results at the top of the screen, but strobe crosstalk is significantly worse at the bottom of the screen, creating quite a bit of blur. In contrast, Pulsar looks basically the same at the top and bottom. Also, you will have again noticed red fringing with the previous 1440p 360Hz ULMB2 panel in the PG27AQN, which isn't an issue on the new Pulsar panel despite otherwise featuring similar specifications. Here's Diac 2 running on the BenQ XL2586X, which also uses regional backlight pulsing. Like Pulsar, you get basically the same clarity results at the top, middle, and bottom of the screen with Diac 2. However, Diac 2 requires a fixed refresh rate, and as you can see from the results, it's actually not as well optimized on that 540Hz TN panel as Pulsar on the latest 360Hz 1440p IPS with more double images. Some parts of the image are a little clearer, but overall the Pulsar result is better while also working with VRR. Next up, let's take a look at Pulsar compared to the best strobing implementations available in other monitors running at their absolute peak configurations for the best clarity. In my opinion, this is a clear upgrade on ULMB2 in the PG27AQN, making this the best monitor for 1440p strobing yet. Some aspects of ULMB2 are a little sharper, but ULMB2 has much more noticeable strobe crosstalk, and that panel has red fringing. Text is still highly readable on the new Pulsar monitor in this super fast motion test configuration, even if it's not quite as good as ULMB2. Diac 2 on the XL2586X is also not as good, with more strobe crosstalk, so again I prefer the way Pulsar looks. The most competitive of the options is ULMB2 on the TN-based Asus PG248QP at 540Hz. Pulsar has less strobe crosstalk and the benefits we've been talking about throughout this review, like VRR support and elite clarity across the entire panel. But ULMB2 on the PG248QP is very clear with less sample and hold blur. Elite fixed refresh strobing at even higher refresh rates will still remain in the top position for overall clarity results at the highest refresh rate, but I think the associated downsides make G-Sync Pulsar the superior solution for most gamers, given what we're talking about are small differences in practice. I'll throw in OLED here using no black frame insertion. Pulsar is generally clearer than 540Hz WOLED panels, which are currently the fastest available at a 1440p resolution. This makes sense when we compare the effective refresh rates of each calculated on paper. With OLED, you get a 1.5 times boost compared to an LCD typically, so 540Hz OLED is roughly equivalent to 810Hz LCD. With Pulsar, you get a 4x boost in clarity, and while the baseline refresh rate is lower, this puts the effective refresh rate at 1440Hz, higher than OLED, and this plays out in the test results. 720Hz OLED is more competitive with an effective LCD clarity of 1080Hz, but even then I still think Pulsar at 360Hz is clearer. And on top of that, Pulsar gives you better clarity at lower refresh rates, whereas OLEDs, without any form of BFI, suffer from the usual sample and hold motion blur issues at lower refresh rates. Here's a look at strobing with all of these configurations set to 240Hz. You can see Pulsar looks superior to a 240Hz QD OLED, definitely better than strobing sync on the M27Q3 as well, and it's competitive with ULMB2. The PG27AQN is sharper and clearer for large parts of the image, but also suffers from more pronounced red fringing and more strobe crosstalk. Now you can also run the XG27AQ NGV in a ULMB2 configuration by disabling G-Sync in the NVIDIA app. This doesn't change motion clarity all that much at fixed refresh rates, so it doesn't give you the same implementation as ULMB2 on the PG27AQN. That older mode had settings that allowed you to control pulse width to gain clarity at the cost of brightness, which is not available on the XG27AQ NGV in its ULMB2 configuration. At this point, you've seen the results from G-Sync Pulsar, which are very impressive. So how does the technology actually work? NVIDIA say they've been able to get strobing working with VRR through the use of a compensation pulse. Essentially, during variations in frame rate, Pulsar strobes the screen twice, rather than the usual once, which helps to avoid flickering. A sudden drop in frame rate could cause the off portion of the strobe to linger on screen for longer than expected, causing you to perceive a dip in brightness as flicker, hence the need for this compensation. Other manufacturers have tried a similar level of compensation. For example, Aim Stabilizer Sync on Gigabyte monitors strobes the screen multiple times per refresh cycle, but every time you strobe the screen beyond the first strobe, you get increased levels of blur. G-Sync Pulsar is a much more clever implementation of this compensation strobe than what NVIDIA appears to describe, and this is why it's so much more effective than other strobe plus VRR solutions. Looking at how the strobe works through an oscilloscope, I spotted much more dynamic behavior than I expected. Pulsar adjusts the main strobe's width and height depending on the refresh rate, producing consistent brightness output without brightness flicker. In this example, I start with a 360Hz refresh rate that has more strobe cycles at a lower amplitude. Then as I decrease the refresh rate into the 200Hz range, then into the 100Hz range, the amplitude of the strobe increases and the width is modified as well. If the strobe's width and height remained constant at lower refresh rates, brightness would drop noticeably, so doing this sort of thing is essential. But the compensation pulse is especially interesting. This second pulse only appears during significant frame rate changes and disappears over a second or two. If the frame rate is relatively consistent, Pulsar either doesn't use a compensation pulse at all, strobing the screen only once, or uses one that's very small. If there's a large change in frame rate, Pulsar produces a larger compensation pulse and reduces that compensation over time if the frame rate remains stable. You can clearly see this in action viewing the light level output on an oscilloscope. If I drop the FPS rapidly from 240 to 120 FPS, you can see the compensation pulse fire into action, then decay over time. It's a brilliant solution. The consequences for implementing a second strobe like this is that in the event of a large change in frame rate, the screen gets blurrier for about a second or so. But then what you see is the screen appears to quickly clear up if the new frame rate is roughly maintained with no additional large fluctuations. This brief drop in clarity is super rare to see in actual gameplay because it requires a massive change in frame rate, but it's a much more tolerable trade-off than flicker or brightness changes. It's also very difficult to capture on camera because it happens so quickly. I'd basically need a motion-controlled robot to show it to you, but yeah, that's basically why we don't have any examples of that in this video. What else is there to know about G-Sync Pulsar? Well, this is the first G-Sync implementation to move away from NVIDIA's proprietary modules to using a MediaTek solution from their partnership that was announced a while ago. This means this new wave of G-Sync monitors has a much better feature set because everything is built on a more modern and robust display scaler. For example, we are finally getting HDMI 2.1 support at 40 gigabits per second, which for some reason is limited to 120Hz on this display when it should be capable of the full 360Hz or at least 240Hz, so maybe that will be solved through a firmware update, but we do get HDMI 2.1. There's a Pulsar low FPS setting in the OST which controls the minimum refresh rate at which Pulsar will begin strobing. By default this is set to 90Hz, but you can manually lower this to 75Hz in the OST. NVIDIA claims 90 is optimal to avoid flickering. Anything below that they cannot guarantee a flicker-free experience. In my testing, transitioning in and out of this minimum is pretty smooth with no real issues apart from strobing being disabled. NVIDIA also say they will release a Pulsar firmware update in the middle of January that will lower the minimum strobed refresh rate to 48Hz for people to try, though again, they recommend gamers use at least 75 if not 90Hz. The latest G-Sync monitors supporting Pulsar also introduce support for a feature called Ambient Adaptive Technology, which uses a sensor to automatically adjust brightness and color temperature based on the ambient lighting in your room. I briefly tried this out and it seemed to work pretty well, though it's not personally something I would use as I prefer my display's output to remain consistent regardless of lighting conditions. Lastly, G-Sync Pulsar only works on NVIDIA GPUs. Pulsar cannot be enabled at all on an AMD Radeon GPU, and it requires the latest NVIDIA display driver on a GeForce GPU. This is really disappointing, as buying a display should never lock you into using a single GPU brand and puts us back to the bad old days where G-Sync variable refresh only worked with NVIDIA GPUs until they finally relented to enable broad support in new monitors using the G-Sync module after many years. It doesn't seem like Pulsar should require any form of driver integration as it's largely display side, but I'll have to get more clarification on this from NVIDIA at CES, just did not have time to do that before publishing this video. Anyway, that's G-Sync Pulsar, a very impressive backlight strobing technology that in my opinion is clearly the best solution currently available. It's the first version of this technology that I would genuinely consider using on a regular basis, as it just works incredibly well with variable refresh enabled. I think gamers after the best motion clarity, especially for multiplayer titles, will be super happy with these latest 1440p 360Hz displays that integrate Pulsar. And not just for Pulsar, because the IPS LCD panel is far superior to TN LCDs that were routinely used for esports strobe-focused gaming monitors, both because it's larger, 1440p resolution instead of 1080p, and obviously the color quality differences that you get with IPS. I'll be fully reviewing the Asus ROG Strix XG27AQ NGV when I get back from CES. I just didn't have the time to check out the entire monitor in depth for this video, but there's plenty more to go over in a couple of weeks. However, you should be able to buy a G-Sync Pulsar monitor shortly, not just from Asus, but also from Acer, AOC, and MSI, with 4 monitors forming the initial wave of Pulsar displays, all using the same panel hardware. Anyway, that's it for this video. If you do want to support our independent testing, we have Patreon. Links to that is in the description below. If you sign up, you get access to some pretty cool benefits. Thanks to MSI for bringing us out to CES 2026. You'll see plenty more videos on the channel shortly from the actual trade show floor. And yeah, that's it. Thanks for watching. I'll catch you in the next one.